Assalamu alaikum, dear students. Today we will study about wind power or wind energy. Okay, as we all know that wind power or wind energy, that is another alternative source of energy. It's an alternative source of or it's a renewable resource that has been exploited in other regions also across the world for quite some time. Like for example, if I'll give you example of Holland, that's in Europe, and United States of America. Pakistan has the advantage of having high wind speed across most of the country, and these should be exploited to generate power at an affordable cost. Okay, human beings, they use wind power or its kinetic energy for many purposes, like for sailing, for flying kite, and even generating electricity. In the recent year, wind energy has emerged as a clean source of energy. As you know, as it is a renewable source of energy, so it's a clean source. It is environment friendly source of energy. The term wind energy or wind power describe the process by which the wind is used to generate mechanical power of electricity. Windmills and wind pumps convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks such as grinding grains or pumping water from underground. How do turbines work? A wind turbine has a generator. As you must have seen the structure of wind turbine, they are long, huge, long towers, right? That is connected with three blades. Um, and this wind power, behind these three blades there is a gearbox, right, which increases the velocity of the speed of wind. Okay, wind turbine has a generator which converts this mechanical power into electricity. Then large scale wind farms, which consist of many turbines, are connected to electrical grid, as we have studied about national grid system, which provide electricity to larger area. But if we install individual turbines, it can provide electricity to very small area. On a smaller scale, it can work. Now, the potential location, the feasible location for wind turbine means where can we install wind turbine, right? In Pakistan, the coastal areas of Pakistan and mountainous areas, they have a very high wind potential. These are the wind potential areas, right? And these areas like coastal areas and mountainous areas, they are considered as the most suitable for generation of wind power, right beta? Okay, the coast of Pakistan is about 1000 kilometers long, as we all know that, and has a population about 10 million people. So demand is also more. High wind is available in that area all year around, right? So um, it is observed that the annual wind speed in Balochistan, like if we talk about, we know that the coastal belt is there, Makran coastal belt is there, right? In the southern part of Pakistan, where the Ormara, Jiwani, and Pasni is there, and Karachi is also there. In such areas, the wind is available throughout the year, right? And that these are the most favorable locations to install wind farms to generate electricity through that clean source of energy, right? Okay. Uh, there are some advantages and disadvantages. Okay, before going to those advantages and disadvantages, right? Let me tell you some of the examples. Like right there, those two examples are there right in front of you in the slide. One is Jhimpir Wind Power Plant, that is in Sindh, and another one is Act Group Wind Power Plant, that is also there. Okay, now the alternate, these are AEDB, Alternate Energy Development Board. They have supported public and private projects in the field of alternative sources of energy, right? They have initiated different projects, as I gave you example of Jhimpi project. That Jhimpi, it was a Pakistan's first power plant, Jhimpi in Sindh, right? And this project was developed with the collaboration of Turkish power company and became operational in 2002. Then another example is Fauji Fertilizer Company also plans to set up wind energy plants in Jhimpi with collaboration with the German and local engineering companies. Uh, Other than that, such the other plants are also set up in Gharo, Keti Bandar, and in Port Qasim. The last, the Keti Bandar and the Gharo, they are very near to Arabian Sea, right? Okay. The federal government, they also have some plans for more wind powered plants in Sindh and Balochistan with the help of by the help of these Chinese government, right? Through that CPEC project, also different thermal power plants, wind power plants, HEP plants. Uh, these all will be established in Pakistan. Other examples are also there. They all will be inaugurated in Pakistan in order to overcome energy crisis in Pakistan. Okay, what are the advantages? Advantages of wind power plant is, as we know, that it's a renewable resource. It will never deplete, it will never run out, right? Okay. Another advantage, it is environment friendly. Unlike fossil fuels, it does not pollute the environment, right? Then wind farms, they are very interesting feature. If you must have observed while traveling from Karachi to interior Sindh and all in Jhimpi, it provides a beautiful landscape for the tourist, right? When it can boost tourism also. These sort of structures can boost tourism. Through that, tourism, revenue can be generated. Wind turbines are available in wide range of sizes depending on the requirement, right? That is also, it means that the different sizes are available. Through that wind power plant, it can help solve Pakistan's energy crisis. And then through that, industrialization can be boosted in Pakistan. Agricultural expansion can be done, like cotton textile industries, other industries, iron steel industries, small cottage scale industry. They all can be flourished in Pakistan. Sports industry, right, where the energy is being used. Wind farms provide the source of income for farmers and may attract small industries to rural areas of Pakistan. There are some other, so many advantages are there. Now let's talk about disadvantages. Okay, wind turbines are expensive to build and increase, which thus increases the burden on economy, Pakistan's economy. Okay, um, it is dependent. The another disadvantage is it is dependent on wind. So when the wind speed is there, wind is high, then it can work and energy can be produced. Otherwise, the wind through that, if there is no wind, right? So what happens? The energy cannot be produced. So it means it is not the constant source of energy. Okay. Wind turbines can kill the birds and bats and harming the fragile balance of in the ecosystem. For the establishment of large wind farms, evacuation, uh, deforestation, to clearance of the land, right? All these things need to be done, right? So, which again, if the deforestation is there, it damages wildlife habitat. Evacuation is there, people they lose their homes. It again, it might take up the large agricultural land. Also, the large huge land is taken up by that, that can be used for another purposes like to accommodate population, for agricultural activities, to establish other industries and all, right? So huge land is being used for wind farms. Okay. um Maintenance cost is also very high, right? So again, it's a burden on Pakistan's economy. So that was all from wind turbines. Now let's watch a video, and through that video we will know the process, how do wind turbines work, and how is it responsible to create to produce energy. Let's watch that video, and please make notes in your journals.
What is a wind turbine and how does it generate electricity? Wind power, components, accidents. Wind turbines are devices that convert the wind's kinetic energy into electrical energy. We can simply describe the wind as moving air, caused by differences in atmospheric pressure between different regions of our planet. Differences in atmospheric pressure arise as a result of temperature differences. When the air moves from a high-pressure region into a low-pressure region, we feel the moving air as wind. On the other hand, we can describe wind energy as the process in which wind is used to generate mechanical energy or electricity. Since the beginnings of civilization, man has always took advantage of wind energy, from the simple sailboats to the grinding of grain with windmills, up to the actual production of electricity thanks to the wind energy converters, also known as wind turbines. There are different types and different sizes of wind turbines. In this video, we will focus on the most common horizontal axis turbines. We'll find out which are the main components of this particular type of wind turbine. We will understand how these devices are able to transform wind energy into electric current. We'll see why wind turbines don't have more than 3 blades through the observation of their airfoil shape. And we will also see what are the main causes of accidents that occur during the operation of these devices. The first wind turbines were built towards the end of the 19th century with the aim of supplying electricity to small, isolated villages. In the following years, the gradual structural and technological improvements of these devices allowed the creation of real wind farms entirely dedicated to the production of electricity. Nowadays, there are about 26 companies in the world specialized in the production of wind turbines. JAES, besides being a qualified partner for some of the most important wind turbine manufacturers, is constantly engaged in the supply of all those spare parts necessary for the production, assembly, repair, and maintenance of wind turbines. As we already mentioned at the beginning of this video, wind turbines transform mechanical energy into electrical energy. The wind energy caught by the wind turbines is in fact transferred thanks to a mechanical shaft to a generator. The generator transforms the rotation energy into electrical energy, which in turn is transferred to a transformer, usually placed at the base of the wind tower. The transformer acts as a link between the wind turbines and distribution grid. It steps up the low output voltage from the generator to higher distribution voltage level. Let's take a look at the various components of a wind turbine. This is the tower, one of the most important parts. It represents the supporting structure of the wind turbine and has the function of absorbing the vibrations generated by the rotary motion of the blade. These are the blades, which are aerodynamically optimized to capture the maximum power from the wind and transfer it to the rotor hub. Each blade is usually 20 meters or more in length, depending on the power level. The rotor is the rotating part of the wind turbine. The rotor hub holds the wind turbine blades while connected to the gearbox via the low-speed shaft. Here, we can find the pitch control system. Thanks to the pitch control, blades are turned in their longitudinal axis to change the angle of attack according to the wind directions. This mechanism also blocks the rotation of the rotor when the wind is too strong or too weak. The nacelle is instead the enclosure of the wind turbine that houses all of the generating components, including the gearbox, the braking system, and the generator. but also the pitch control system and the yaw system, which is responsible for the orientation of the wind turbine rotor towards the wind. An anemometer placed at the rear of the nacelle, in fact, constantly detects the wind direction. Whenever there's a change in wind direction, the anemometer sends a signal to the yaw system that provides to rotate the entire nacelle and consequentially the rotor and the blades to meet the wind at the best angle. But now, let's see in detail what happens when the wind turbine goes into action. The blades start to turn when the wind reaches the so-called cut-in wind speed. That is, the point at which the turbine starts generating electricity from turning. The rotor is connected to the drive shaft, which rotates inside the nacelle. The rotational energy of the drive shaft is transformed into electrical energy by the generator. A generator is in fact a device that uses electromagnetic induction to produce electrical voltage. One of the main elements of the power transmission of the wind turbine is the speed multiplier. Since the rotor blade rotation is low, the speed multiplier inside the gearbox is used with the aim to reach higher levels of the rotational speed needed by the electric generator in order to produce the electrical power. Most wind farms are also equipped with inverters that convert direct current into alternating current at 220 volts, making it suitable for grid feeding or self-consumption. If the wind speed increases, there will be a gradual increase in the instantaneous power of the turbine until reaching the rated wind speed. That is, the wind speed in which the generator reaches its rated power output. As the speed increases above the rated wind speed, the forces on the turbine structure continue to rise and, at some point, there is a risk of damage to the rotor. As a result, the braking system is employed to bring the rotor to a standstill. This is called the cut-out speed and is usually around 25 meters per second. We've already said that the turbine's blades start to turn when they're hit by the wind. If we look closely, we can notice that the blade has a lot of airfoil cross-sections consisting of different sizes and shapes from the root to tip. The teardrop shape of the blade is very similar to the aerodynamics of the wing of the aircraft, which we've already discussed in our previous video. In that case, the airflow hitting the wing followed precise trajectories, allowing the molecules of the lower surface to have a higher density than those of the upper surface. The difference in pressure between the two parts allowed the wing, and consequently the whole aircraft, to lift up. Also in this case, the lifting process of the wind turbine blades is very similar. Thanks to the pitch control mechanism, the blade is tilted in order to be always aligned with the airflow. When the blade speed is increased to the tip, the relative wind speed becomes more inclined towards the tip. This means that a continuous twist is given to the blade from the root to the tip. By observing the operating principle of wind turbines, we may be led to believe that a turbine with many more blades is more powerful than one with 3, 2, or even a single blade. This conclusion has some truth. More blades allow you to achieve more power, but the more blades there are on a wind turbine, the higher will be the torque, which is the force that creates rotation. And the slower the rotational speed, because of the increased drag caused by wind flow resistance. So, a wind turbine with many blades will be more powerful but less efficient than one with less blades. A wind turbine with 3 blades placed at 120 degrees from each other represents a good compromise between power and efficiency. A turbine with 4 blades means more weight and therefore more costs. Also, a wind turbine with 2 blades will obtain similar performances but would require bigger dimensions and therefore higher costs. We have seen so far that the design and implementation of a wind turbine involves a series of structural choices that are not directly linked to the power of the wind turbine, but take into account factors such as costs, maintenance, noise pollution, landscape assessment, and many others. Maintenance still represents a fundamental element for the correct functioning of these devices. Unfortunately, many accidents still occur if regular maintenance activities are not carried out. The causes of these accidents can be mainly attributed to fires related to the malfunctioning of internal components or lubrication system, damage caused when foreign objects make impact with the blades, bad weather conditions or thunderbolts. Finally, if you found this video
Okay, that was it from my side. I hope you have understood the video and you would be able to make notes, right? Now, inshallah, in the next video, we will be discussing about solar energy, right? Thank you so much for your time, and make notes, complete your journal and make notes in your journal. Allah Hafiz from my side.